Here's a submission from RaptorMan1218, just looking for general advice. Setup is a D quad 5-inch. I'm not familiar with that. Let's have a look at what that is first of all. D quad 5-inch. So it just looks like a, no, this one. There we go. Looks like a typical sort of 250, 210 type frame. Nothing really remarkable here. Jumps out that might affect the handling or the tune, so fine. So nothing remarkable about this setup that might directly affect the tuning or the handling. It's all fine gear. Let's take a look at the log and the video next. And the first thing I'm going to do is I'm just going to take a look at the video. There doesn't appear to be any audio, but I'm just going to take a look at the video and see if there's anything that jumps out about the handling. And you can see I've turned off the traces, so we're not even going to see anything like that. In fact, oh, how about that? We can turn those off too. We can just look at the video. Here we go. There's a little bumpiness here. Unclear whether that's tuning related or maybe it's just windy or maybe the camera. Bumpiness. Maybe you look for vibration. A little bit of rebound there at the end of the flip. That bumpiness could be imbalanced motors. It could be excess D-gain. Or it could be maybe the camera's loose or the lens is loose. Any number of things. A little bit of rebound there. So, fine on the slow move. Fast moves have some rebound. So, overall, the copter feels undertuned to me. It feels a little bit soft, and I might like to look for more P gain, would be my first thoughts. We had a little bit of bounce back after the flips and rolls. That can be low P gain. And if it's low P gain, that means that there's not enough authority to stop the flip or roll sharply, and the copter sort of overshoots and bounces back. You can also get a bounce back like thing after flips and rolls with high P gain, in which case I would typically expect to see a sort of a ringing oscillation as opposed to just sort of more like a single softer bounce back. This is just my initial impressions based on what I'm seeing in the video, and of course the Blackbox log will give us more insights. Unfortunately, we don't have a command line dump, and whatever firmware version is being used here doesn't seem to be giving us the header information that would have the complete PIDs. So we don't know what your current PIDs are. Everybody, if you submit, please submit a command line dump and a log and a video. Those three things together are the best. So let's take a look now at the Blackbox logs. We'll start with the gyros, as usual. Zoom all the way out. We'll look at how clean the gyros are. Gyro traces are very thin, very clean, almost too clean, I've started to say, depending on what firmware version you're at. I almost even wonder whether you're using the Gyro LPF. Gyro LPF is the hardware filter, which is built into the MCU chip, the gyro chip on the board, and it's very sort of more aggressive filtering and produces traces like this. These are very, very clean traces. In most scenarios, I would recommend filtering less than this. If your traces look this thin and clean, you probably could stand to have less filtering. At least on modern versions, CleanFlight 1.13, Betaflight 2.7, 2.8, you could probably stand to have less filtering. Now, if you're running Betaflight 2.7, your traces probably don't look this clean because in Betaflight 2.7 and presumably also 2.8, Boris made the default filters less aggressive. And that means that you get more noise, but also better handling, better performance. So my guess would be that you're running an earlier firmware, like perhaps CleanFlight 1.12 or maybe a Betaflight 2.6.1 or something like that, which is getting this level of filtering. You essentially never see traces this clean without being heavily filtered. And especially given that I saw that vibration in the camera, that tells me that this copter probably is not got super duper smooth motors and props, but even then this would be really clean traces. So this gyro trace doesn't really tell us a lot because it's so clean. It's indicating that it's probably heavily filtered, at which point we really don't know what's going on underneath. Let's know, just is what it is. Let's look at the roll axis next. And actually, I can't remember if you did a flip or a roll first, but let's find that flip or roll with the bounce back. Okay, so there's a flip with some bounce back. Well, so we'll go to the pitch axis then, since that's where we're at. And I'm definitely going to also want to see your pitch RC command to confirm there we go. To confirm that you didn't do this with your thumbs. So, as we look at the move, RC command is going up, your pitch stick is being pushed forward, and we can see the gyro going up as well, coming forward. That indicates that the gyro is moving with the stick. The gyro is, yeah. We can see the P term rising as the stick rises to push the copter into the move. The P term is pushing the copter into the move, and the gyro is responding. We can see that during the flip, the I term is positive. Now, in some versions of Betaflight, it will limit or even zero out the I term during a move like this, and that is desirable. During a move like this, we don't want the I term accumulating any accrued value. The move is going to end very soon, and we want to sort of go back to zero. If the I term accumulates value during the flip, it can then try to unwind that value at the end of the move and cause a rebound. So that's something we'll definitely be looking for. And here you recenter the stick. As you recenter the stick, the P term goes negative, slowing the move down. Here is the point. We see the gyro here. The gyro begins to decrease as the copter slows down. This point here where the gyro crosses the zero line is where the copter is absolutely stationary, and now as the gyro goes below the line, the copter is rebounding. It's coming back the other direction. So this little bit here is your rebound, and then this is just a little bit of a bounce. So it stops, it rebounds, it stops, and then it continues again. So it's like a kind of a stutter. We can see here that RC command is absolutely zeroed during this move. So this is not a case where you sort of wiggled the stick and caused the rebound. This is absolutely a tuning related thing. Now, if you had less good ESCs, I would blame your ESCs perhaps. If you have ESCs without very strong braking and just overall good performance, it can result in loss of performance during sharp moves like this, like where you're rapidly stopping a flip, and you can end up with little bounces and overshoots. But you have KISS 30 amp ESCs, which are very good ESCs, and we can't really blame them for anything that's going on. So you really should be able to tune this out. Notice that during the bounce, the P term goes positive and is trying to fight the move. The PID loop knows that this is not supposed to be happening and is trying to oppose it, but is failing. Also notice that the I term is pretty close to zero at the end of this move. And in fact, as you recenter the stick, the I term goes negative with the P term. So the I term and the P term are working together to stop the move. So the premise that we have some issue with the I term causing the rebound is not true. Usually what we would see in that scenario is that the P term would be negative trying to stop the move, but the I term would be strongly positive, and they would be fighting each other. And the I term would basically win, and you'd end up with a rebound. That's not what we see here. We see that the I term and the P term are the same side of the line. They're both negative, and they're both working together to stop the move. So we can't blame the I term for this bounce. So what is the cause of the bounce? Well, like I said, I feel like this copter feels undertuned. Just looking at the moves you do, those soft single bounces at the end of the move, that's usually indicative of low P gain. The copter is trying to stop the flip or roll and just doesn't have enough authority to get it done. And so then it sort of slides to a stop and overshoots and bounces back, and just not good. And I feel like I would be increasing P gain on both pitch and roll in order to try to find the limit for where P gain is too high. My recommended tuning method is to raise P gain until you see clear signs that it's too high, and then lower it even until you see clear signs that it's too low. The copter feels unacceptably soft, and that'll give you a range to work with, and then you can sort of find where in that range you like it best. But if you've never raised P gains until the copter definitely is too high, then you just don't know. And in this case, it feels to me like the P gain is too low, at least on the roll axis and probably also on the pitch axis. We can confirm that by looking through this log and looking. So here's a case. I see the P term sort of moving and surging here. You can see the line, these sort of rolling hills. That's the P term working, and that's good. Ideally, I would like to see some scenario where you've got actual oscillation at least starting to come out. Now and here's the full throttle. Let's see what happens during full throttle. So here you're at full throttle, and again, we don't really see the P term getting super active. Yeah, so what it feels like to me is that it's undertuned. We just don't see a huge amount of activity on any axis, P, I, or D. So it feels to me like it's undertuned and like you can raise the P. And the first thing I would do then is raise the P gains. The vibration bothers me a little bit. I would really want to solve that if this was my copter. It would really bother me. But that could be something as simple as you just need more vibration damping on your high def camera. It doesn't necessarily mean that that's something that is tuning related. But yeah, that vibration there would really bother me. Oftentimes I would call that excess D gain, but we just can see here that the yellow line is not at all noisy or dirty or whatever you want to call it. It's just super docile. So it's not excess D gain here. And maybe just have, if this was a 6-inch copter, I would blame the props maybe, but it's not. It's a 5-inch copter. So I don't know. But that normally, see, the thing is, normally if you have vibration getting into your high def camera, it'll look like jello. It won't look irregular like this. You see how this is kind of bumpy and irregular. It's not like it's not like a high frequency vibration. And it suggests to me that it may be something to do with your tune, but gosh, I just don't know what it could be. Alrighty, well, I hope that's all helpful. Happy flying.